Today we're going to talk about how we name polyatomic ions and acids. We have already spent some time learning our polyatomic ions, but let's go through how we came up with these names. So basically the prefix and suffix in the polyatomic ion can help us figure out what's going to be in the polyatomic ion. So let's look at the prefix first. If there is a hypo, that means that there is less than normal. Now, what we're talking about is oxygen. And if we see the prefix hyper, that means that there are more oxygen than normal. The suffix is going to help us also determine oxygen. So if we have an ITE ending, this means that we have one less oxygen. And if we have an ATE ending, that means that we have one more oxygen. Notice how I'm not actually putting a number to what more and less means, because that's going to depend on the other nonmetal that's involved. And we see that here in this slide that for some of our polyatomic ions, more is going to mean 4, and for others, more is going to mean 3. So it's really important that we are using our reference packet to help us decide what's more and less for each individual polyatomic ion. So in your reference packet, we have an entire series, and that's the chlorate series. So this is going to help you remember how to do this sort of rearrangement. So here we have ClO4 minus 1, ClO3 minus 1, ClO2 minus 1, and ClO minus 1. Like I said earlier, the prefix per means more. So this means that we have one more oxygen present than we do in the 8 format. So if we look at chlorate, that has 3 oxygens. So having one more than that is going to be our per. So having in the chlorate form, having 4 oxygens is going to be the per 8 format. Now we said that the ITE ending means one less oxygen. So we're talking about one less than whatever the 8 was. So the 8 was O3. So that means our ite ending will be O2. We said hypo means less than normal. So hypo goes along with the ite. So we're talking about one less oxygen than the ite format. So the ite is O2. So the hypo-ite is going to be just 1. And again, the 4, the 3, the 2, the 1 only applies strictly to the chlorine series of the polyatomic ions. If we notice that we have sulfate over here to the right, our sulfate has 4 oxygens. So if we wanted to change this to the per-sulfate, we would have to increase this 4 to a 5, which is different than our chlorate one, but we can still use our prefix and suffix to figure out how many oxygen there will be. Basically, all you need to be given is 1 in the series. So like if we're talking about our sulfur series, we just need to be given either sulfate or sulfite so we can determine what ending goes with which number of oxygens. And then the nitrate series here, the ATE ending has 3 oxygens, so the ITE ending would have 2 oxygens. If I were to ask you for the hyponitrite, that would only have 1 oxygen, and then the per-nitrate would have 4 oxygens. So this is how we are going to be naming our different polyatomic ions. You need to know what these mean. So if I give you SO3 minus 2, you have to be able to say that that's sulfite. Or if I give you the SO2 minus 2, you have to be able to tell me that that is hyposulfite. So, but you always will have your list of polyatomic ions that you can use, but they may not always be on there. So you have to know how to change it. And again, this chlorate series will really help you with that. It's important that we understand those polyatomic ions because we're going to have to alter them when we get into acids. So this is how we name acids. The name of the acid is always based off of the anion. So the cation will always be hydrogen because an acid is an anion that's combined with a certain number of hydrogens to make it neutral. So let's first look at naming acids that do not have a polyatomic ion present. So it's just like our binary ionic compound. The end of an anion that's binary, so no polyatomic ions, is an IDE ending. So if we ever have just an anion that came from our periodic table, so it has an IDE ending, the name of the acid is going to start off with the prefix hydro and then end in acid. I'm sorry, this is supposed to be an ic also. So it should be hydroic acid. For example, HCl starts with hydrogen, so we know it's an acid. The anion's name is chloride, so it's going to change to hydrochloric acid. We're going to get rid of that IDE ending, change it to an IC, and add ic. So hydro as your prefix, chlor as your root, and then ic as the end. Now, if you have a polyatomic ion present, it's going to change a little bit. So we have to know our names of our polyatomic ions in order to convert it to an acid. So any prefix that's on our polyatomic ion is going to stay. So if our anion is hypo, root word, ite, it's going to go to hypo blank us acid. Ite will always change to OUS. Ate will always change to ic. And again, any prefix that we have will remain the same. So for example, I did the whole chloric series. So if we have hypochlorite, that's going to change to hypochlorous acid. If we have chlorite as the anion, and again, we have our hydrogen out in front, which helps us figure out that it is an acid, it's going to change to chlorous acid. HClO3, we know it's an acid because there's a hydrogen paired up with an anion. And if we look at ClO3, we can figure out that that is chlorate. The ATE ending will change to ic, so it would be chloric acid. HClO4, if we look at ClO4, we know that that is the perchlorate ion, so it's going to change to perchloric acid. It is important that you understand how to do this.